there, ROS developers. Hello, everybody, and welcome to a new open class number 156. And today we are going to be talking a little bit about software testing, specifically for ROS2 in this case, and using GTest, the Google testing framework. So yeah, I think it's going to be a pretty interesting class. We have many things to cover. So let's get started. Let me know, as always, in the chat if sound is good and if everything is correct, so that we can start with the class normally. So yeah, let me have a quick look here. Yeah, so let's switch already to my computer screen. Let me do that right now. There we go. Okay, so here I am in the computer screen. Here you can see my computer screen. So let me go to the class so that I can see your messages and your feedback very quickly. Yeah, actually, let me come from here. Feedback very quickly. Yeah, actually, let me. Okay. No messages so far. So I'm going to assume that everything is correct, that you can hear me and see me properly. Then yeah, so let's then get started. So as always, the first thing that you need to do in order to start the class is to get the rosject. So this can be done very easily just by clicking on this button here above the chat, which says fork, and open the class rosject. So I'm going to click here myself. Then this is going to automatically create a copy of this rosject into your account. And as you can see, it's going to also automatically open the rosject page, which is this one that I am right now. So here at the right side, as always, you have the streaming area with the live stream and the chat. I'm going to keep monitoring here the chat in case that you write any comment, you have any doubt, whatever. So yeah, let me just close all these for now. Okay. Then by default, you should get this Jupyter notebook loaded in your rosject. So after, as you can see, after some seconds, the rosject page should load normally, and then you are going to be able to visualize to see this Jupyter notebook. Yeah, this is the notebook that it contains all the instructions of the class. It contains all the step-by-step guide of what I'm going to be doing and teaching today. All right. So yeah, I'm going to give some seconds here. So let me know if everybody is properly set up. Are you inside the rosject? Yes, no, any issues so far? Okay, I can see here Cristobal Arroyo saying that everything is okay. All good. Also, Matthews. Okay. Then perfect. Then let's get started. As you can see, today we are not going to be launching a simulation. Okay, we are going to be working without a gazebo simulation. So we are going to stick with the very basics. Yeah, we are going to do an introduction to software testing in general, but to Google test in particular, and in this case, combining it with ROS2. We are not going to be using directly ROS2 code, okay? But we are going to be creating a ROS2 package, and basically we are going to see how to integrate the testing framework, how to integrate GTesting into a ROS2 package, okay? So we are going to go from there. Then, first of all, what is software testing? So I suppose that most of you can tell me what is software testing, but yeah, basically is to create a set of tests that make sure that the code that you create is working correctly. Yeah, and it's going to provide the expected results. And this is very important, especially when developing in any kind of development, but of course also in robotics development. Yeah, especially when you are working with collaborative repositories where many people is going to do, it's going to be pushing code and so on. It's very important to have some kind of tests to make sure that everything keeps working as it should. Yeah. Then if you want to become a robotics developer, of course, you need to know about software testing, yeah? Especially if you are going to start working on at a company, developing code, it's very likely that you are going to have to create some kind of testing, yeah? So it provides many, many advantages. You can read some of them here in the notebook. But today, in this class, we are going to be focusing on GTest. GTest is a framework which has been developed by Google, and it's used for. In this case, it's being used in some very important ROS2 packages like navigation 2. Yeah, so the navigation 2 packages are being tested using GTest. Yeah, so there are many. What I want to say is that there are many tools that you can use in order to test your software, but GTest is a quite extended one, and as you can see, it's already being used in some very important and core ROS2 packages. So that's why we decided to create a course in the first place about this GTest framework, this Google test framework, and especially for ROS2. Okay, then of course here we are going to just do an introduction, and we are going to start by seeing how to integrate this GTest framework into a project, a ROS2 project structure. Yeah, Mateus, is it just for C++? Yeah, so in particular this Google test is for testing C++ code. Yes. Okay, then we are going to start by creating a typical project structure, okay? So let's start by executing some commands already here in the shells, in the terminals. So we are going to open a new shell, and you can do this very easily just by clicking here in this first icon that you have here in the bottom menu, yeah, this first one. So if you click here, this is going to open here a new shell where you can type commands. And we are going to type these two, first of all, okay? As you can see, you have some icons here that allow you to copy directly the code in this cell with just one click, okay? So you can, for instance, come here and click in this icon, and this is going to copy the code from this cell, as you can see. So now you can come here to the shell and just paste it, for instance, with Control-B, with the shortcut, and then you are going to have the command directly here in the shell, okay? This is going to help you to go faster. So I'm going to do the same here with the second command. I'm going to copy it directly here from the notebook and paste it here into my shell, okay? As you can see, this is a command, a ROS2 command, where basically I'm creating a new package named my CPP library, okay? And as you can see, it's a CMake package, okay? So let me execute this command, and this is going to generate a new package. So now, for instance, if I type here in the shell ls, I'm going to see my new package here. But also you can visualize it through the code editor. Okay, I'm going to open right now the code editor, which is this second icon that you have here in the bottom menu. Yeah. So if you click here, this is going to open here a new window here with the code editor, okay? This is going to basically give you access with a graphical interface to all the workspaces, files, everything that you have inside this rosject, yeah? So in this case, as you can see, we are working in the ROS2 workspace. So if you go here to the ROS2 workspace and you open it and you go inside the SRC folder, you are going to see the new package that you have just created, yeah? This my CPP library, okay? Then in this package, we are going to create a typical CMake package structure. Yeah, so we are going to start by writing a library, and we are going to start by creating the header file. Okay, so here you have the commands to do all this through the shell. Yeah, so here you are going inside the my CPP library folder, inside the include folder of the package, and then you are creating a new header file here with the touch command. Okay, so you can do this. So right now in the include we have nothing. Okay, so I'm going to do this one here using the notebook command so that you can see how it's done. So first of all, I'm going to copy the first command to go to the desired folder, and second, I'm going to run this touch command to create the new file. Okay, then if you come here to the code editor, you are going to see that you have created this new header file. If you open it, you are going to see that it's empty, of course, because you have just created it. Okay, now if you check down here, you're going to see this code. Yeah, so this is the code that we are going to add to the library underscore header.h file. Okay, again, you can copy it directly here using the copy icon. Okay, so I'm going to copy the code here from the notebook, and I'm going to paste it to my header file. Okay, so you are going to have something like this. Okay, don't worry about these errors that are showing here. Okay, you can just ignore them. And yeah, so this is the header file. As you can see, it's very basic. So we are creating this savings account class, and then yeah, so we are defining here some public methods. Yeah, we have here the default constructor. We are defining here a deposit method, withdraw method, get name method, get account number method, and get balance method. Okay, and then in private we're also defining some variables. Then once you have created the header file, we are going to continue by creating the CPP file. Okay, again, you have the commands here to create the file through the shell. If you prefer it, you can just create the file directly using the code editor. For instance, you can come here. Yeah, so in this case, it's creating this CPP file inside the SRC folder of the package, as you can see. Yeah. So first, it's going inside the SRC folder of the package, and then inside here, it's creating this my CPP library CPP file. Then you can do it with the commands, like I have done just now, or you can do it directly through the code editor. I'm going to do this one through the code editor. So inside the SRC folder, I'm going to right-click here, going to right-click in the SRC folder, and then select new file. And now here you can type the name of the file, which in this case it's my_cpp_library.cpp. Okay, and this is going to create again this CPP empty file. Okay, now we are going to repeat the process, and we are going to copy the code from the notebook and paste it into the current file. Yeah, so I'm going to copy the code here from the notebook, and I'm going to paste it here to the CPP file. Okay, there we go. Then what we are doing here is, first of all, we are including the header file, as you can see, and then we are actually implementing the different methods. So here we are implementing the deposit method. Okay, I'm implementing also the withdraw method, get name method, get account number, and get balance method. Okay, so in my header file, yeah, so this is let's say basic C++. So I'm not going to go into details here of the code because it's not the purpose of the class. Yeah, but basically we have the header file where we basically are defining our class and the different methods and variables, and then in the source file, in the CPP file, we implement all these methods. Okay. All right. Then let's keep going. Yeah, so we are building our project structure. Then again, inside the source folder, again, we are going to create another CPP script, which is going to be named main.cpp. main.cpp, okay? So also inside the SRC folder, we are going to create another CPP script named main.cpp. And inside this main CPP, yeah, we are going to copy and paste this code here. So I'm going to copy it using the copy icon and paste it here to the code editor. All right? And here we have the basic structure. Yeah, so this is the basic structure, let's say, of a C++ project, where you have the header file, the source file, yeah, the header file that defines, let's say, the class, the header file, the header file that defines the class, the source file that implements all the methods of the class, and then a main source file also, which is the one that uses this class. Yeah. So in this main CPP file, we are implementing the main function, and then here is where actually we are creating an instance of our class, as you can see. Yeah. So here we are creating an instance of the savings account class. Yeah, providing some data here for the constructor. And then we are also using and calling some methods of the class. So in this case, we are calling the getName method, and then we are just printing it to the screen with a cout. Okay. All right. Now we have to talk about the cmakeLists.txt file. Okay. So always that you create a cmake package in ROS2, yeah, it's going to generate automatically this cmakeLists.txt file. Yeah, most of you probably you have already heard, and you are already familiar with this file. Yeah, so this file, as you can see, I have not created it. It's created automatically when you create a new ROS2 package, which is a cmake package. Yeah, if you create a Python package, this file doesn't exist. Yeah, but if you create a cmake package, which is our case, it's going to generate this file, and this file basically contains all the compilation rules. Yeah, so when you compile this package, the compilation, the build process is going to follow all the rules and instructions that are defined inside this cmakeLists file. Okay. Then here we are going to do some modifications. So we can copy directly the whole file here from the notebook and paste it. Yeah, I'm going to do this actually, and then we can review it. Okay. So let's open this cmakeList file and remove the contents that it has right now. As you can see also, just to point out, by default, this cmakeList file already contains some things. Yeah. Between these things, it contains this if build testing section. Yeah, it contains an if statement here, which says something about build testing. Okay, this is relevant, and we are going to see this later on the class. Okay, just to point it to you right now so that you have it in mind. Okay, then right now I'm going to just remove the contents. I'm going to copy the contents shown here in the notebook for the cmakeList.txt, and I'm going to paste them to my cmakeList.txt file. Okay. Then here we are doing some things. Okay. So let's have a look at the most important parts from here. So first of all, we have here this include directories function. Okay. So here I am, as you can see in the comment, I am telling cmake to add this directory to the target. Yeah. So I'm going to add this include my CPP library. Okay. This include my CPP library. I need to include this directory because inside here is where I have defined my header file. Yeah. So if I don't do this, the project is not going to be able to find my header file. Okay. Then here I am indicating the header file. Yeah, I am indicating to my CMake project the header files that I am using. In this case, the header file that I am using is this library header, yeah, which is inside include my CPP library, okay? And then I have the add library method here, which basically is generating a new library. Yeah, it's going to generate a library named my_lib from this CPP file. Okay? So from the mycpp library.cpp file, from this file that we have created some moments ago, from this file, it's going to generate a new library named my_lib. Okay? Yeah, so basically, summarizing here, I am creating a new library. Yeah? Then down here, we have the add executable method. This method is going to generate a new executable, okay? And it's going to generate an executable from the main.cpp source file. Yeah, from this CPP file that we have also created, it's going to generate a new executable. And then the executable is going to be named main, okay? And then I have to link my executable with my library. Okay? Why? Because my main executable is using a class which is defined and implemented in the library. Yeah? So this mylib library that we have created here, it contains the definition and implementation of this class, the savings account class, right? Then in my executable, I am using this class, yeah? So I need to link, using the target link libraries method, I need to link my main executable with my library, okay? Yeah, and finally here I am installing the executable, okay? I am installing also here the include folder. I am installing also the library. Okay? All right. Then, yeah, so down here you have the explanations also of all these lines that I have been explaining right now. Then, okay. So yeah, now we have already created our project. We have created all the files for our project. So the final step is to build our project, right? So let's do this. Now, we are going to go to the ROS2 workspace. Yeah, remember that to build, in order to build, you need to be in the root of the workspace. Yeah, close this. You have to be in the root of the workspace. Yeah, so you do not compile inside the SRC folder or anywhere else. Yeah, you have to compile in the root of the workspace. Then once you are here, you can run the colcon build command in order to build the project. Okay, and this has failed for some reason, okay? So there is something wrong here. Okay, let me review if I have done something wrong here. CPP. Okay. Did I copy paste something wrong, maybe? I'm not sure. Let me copy this like this. I'm going to remove this. Okay. Let me remove also this one. And copy it like this by selecting. Yeah, this definitely looks better. Okay. So if I compile now, no, it's still failing for some reason. Okay. Okay. Let me also recopy paste the CMake lists. All right. Okay, yeah, now it's compiling. All right, so this is pretty strange. Let me try one last thing. Yeah, let me select everything again, remove it, and copy it using this tool, because maybe this is the problem. Okay, let me try to recompile. Yes, okay. Okay, yeah, so apparently when copying code, okay, there is no problem with the commands, but with the code, there is some kind of issue here that if you copy and paste code using the copy icon here, it looks like something is wrong in this process. So we will check that, okay? Anyways, yeah, so then let's just, in order to copy code, we are just going to come to the cell, select the code, okay? And copy it, okay? You can copy it with Control-C, with right-click and copy, however you want, okay? All right. Then at the end, if everything is fine, after building, okay, you should have something, an output like this, yeah? So not one package failed, but one package finished, okay? This indicates that the project has been successfully compiled. I can see a message here from Janak Panthi. Is there a YouTube link for this stream? I just joined it in and trying to figure out how to start the stream from the beginning. No, Janak. So after this class finishes, we are going to publish the video of the class to YouTube, okay? But the live stream is not available in YouTube. Okay, so it's only going to be available after the class finishes that we will publish the video to YouTube. Okay? All right, then, yeah, so we have compiled our project. Then let's keep advancing, okay? All right. So far we have created a simple C++ project with a library, a main program, but we are not using any kind of testing so far, right? So this is just basic C++ stuff with a class, header file, source file, main file that uses this class, etc. But there is no testing so far. So how do we include testing into our ROS2 CMake project? Okay, this is what we are going to see right now, okay? Then the first thing that you should do is to create a new folder named test inside your package, okay? This is like we are going to do. So this is not a super closed convention, yeah, but in general terms, all the code that you create for testing is going to be inside a folder named either test, tests, something like this, okay? So in our case, we are going to create a new folder inside our package, yeah? So I'm going to right-click here in the package folder and select new folder. And I'm going to name my new folder test. Okay? There we go. So now in my package I have this test folder. Now, inside the test folder, I'm going to create a file named main CPP. Okay? So inside this test folder, let me create a new file named main CPP. Okay? So here you might notice that this main CPP has the same name as this other main CPP. Okay, don't worry. Don't worry, it might be confusing at this point, but they are in different folders, okay? So they are not going to collide. Then we are generating this main CPP because Google Test needs to have an executable, yeah? This executable is going to be used as entry point to the tests, okay? So the tests are not going to be actually performed here, but this is going to be an entry point to the tests, okay? So as you can see, the code for this main CPP file is super simple, yeah? So I'm going to copy it again from the notebook, yeah? In this case, selecting the code and copying it like this, yeah? And then paste it here, okay? So super simple code, as you can see, but notice the first line where we are including GTest, actually, okay? Then, as you can see, we initiate Google Test here, okay? And then we return this run all tests, okay? What this means is that I'm going to run all the tests, okay, of the next file that we are going to create, yeah? So, yeah, we are calling this run the tests, which is going to automatically detect and run tests in the files that you will define in a moment. Okay? So now we are going to actually create the testing script. Yeah? This testing script, we are going to, of course, create it also inside the test folder. Okay? And we are going to name it like this: savings _ account _ test.cpp, okay? Again, there is not a very strong convention on this, but usually these testing files are going to end with _test, okay? So, let me get the name from here, and then I'm going to go again to my test folder, create a new file, and I'm going to name it like this: savings account test.cpp. Okay, now, again, inside this file, I'm going to copy and paste this code. Yeah, very simple for now. So just select the code from here and paste it here. Okay. Now, again, we are including GTest, and we are defining a new test. Yeah. In order to define a new test, you have to use this test macro. Okay. Yeah? Then inside the test macro, you define the test suite and the name of the test, which is my first test in this case. Okay? And then here you are going to add the code for your test, which in this case, it's just a basic assertion. Yeah? This is an assertion which is named expect true. Okay? So this is going to test that whatever it has inside here is true. Yeah? Since here we are actually adding true directly, so this test is going to always succeed. Yeah? Yeah? Does this make sense? Do you understand this expect true line? This assertion? So if I have it like this, this test is going to always succeed. Yeah? What happens if I change this for this? What's going to happen then? Well, then this test is going to fail, right? Because I am using the expect true assertion, but I am providing a value which is false. So this assertion is not going to pass, so the test is going to fail, okay? In this case, we are going to create this test, which is always going to pass, okay? This is just a very basic example to start with, all right? So yeah, always that you want to define a new test, you need to use the test macro, okay? Very important, this test macro. Yeah, then the first parameter is the test suite name, which is a name that you choose for grouping tests, and the second parameter is the name of the test, okay, of this specific test. Yeah, this one, okay. Yeah. Okay, then we have the main executable here, which is going to initiate Google test, and it's going to run all the tests detected. In this case, it's going to run only this one, yeah, because it's the only one that I have defined so far. Okay? And then, as I was commenting, this expect true is a test assertion, yeah? Okay. Now, we are going to update our code, okay, with, we are going to update our CMake list file, sorry, in order to include the testing, okay? So for this, we are going to activate our if build testing statement, yeah? Remember initially that I pointed to you this, that was there present inside the CMake list. So, so far, until now, we are not using this, okay, because we have just compiled a regular CPP project. But if you want to integrate testing into your CMake project, you need to add this section, okay? Yeah, so let's come a moment here. Or we can just add this there in the middle if you want. Let me see. Yeah, so let's do one thing to make sure that we don't introduce any strange errors, okay? So down here you have the full CMake list txt file, okay? So just remove the current one. Let's just remove what we have so far, and we are going to select this, all the code from this new one, and paste it into the CMake lists, okay? Now, basically here, everything is the same as the previous one, okay? So you can see the include directories, the setting the header file, adding the library, mylib, generating the main executable, linking the executable with the library, etc. But as you can see here, we are including the testing section, okay, which starts here in this line, if build testing, and it finishes here in the end if line, okay. All this section is what we have added, okay. Yeah, then first important thing here is that we need to find a specific package, which is this amend CMake GTest, okay? So we need to find, get this package using the find package method, okay? So with this find package method, we are going to make sure that we have access to this amend CMake GTest package. Yeah, this is our required package, okay, for processing all the tests and everything. Then we need to set our test files, which are two. We have the main CPP and the saving accounts test CPP. Both of them are inside the test folder, as you can see. Okay? Now we add the GTest executable. Okay? So in this case, we are adding an executable, a GTest executable, which is going to be named like this, project name underscore test, yeah, from the test files, okay? So here we are setting these two test files, and then we are using these test files to generate an executable. Yeah? And then finally, we have to link also our test executable with our library. Okay? Yeah? And then finally, we are just installing this test executable. Okay? Same as we installed the main executable or the libraries using the install function. Yeah? Okay. So what next? Okay, so next is to actually run our tests, right? Then before running our tests, however, we have to compile, okay? We need to run colcon build. So we cannot run the test directly, but we have to first compile, okay? So let's come back again, come here and colcon build, okay? All right, I have compiled, one package finished, so it has compiled successfully, okay? All right, so now that I have compiled, I can actually run my tests, yeah? And the command to run the tests is colcon test, yeah? So colcon build is for building. You need to build before running the tests, and then after building, you can run colcon test, okay? And this colcon test command is going to actually run your tests, okay? So let's come here and run this colcon test command, okay? All right, so apparently, right, nothing has changed, right? So we are getting the same output of that we were getting with the colcon build command, right? Yeah, but don't worry. So we are going to come back to this in just a moment. First of all, I just want to comment that colcon test is going to run all the tests defined inside this workspace, this ROS2 workspace. Okay, so sometimes you will want to run all the tests from our workspace, but some other times you are going to you will want to run only the tests from a specific package, right? So if you want to only run the tests from a specific package, you can run this next command, which is colcon test. Then you specify the packages select flag, and you specify the name of the package, okay? So with this command, I'm going to copy it from here and paste it. Colcon test, packages select, and the name of the package. Yeah. So this command is going to only run the tests of the myCPP library. In this case, both things do the same because for this example, we only have this package inside the workspace. Yeah. But imagine that you have hundreds of packages inside that workspace. So then it might be a problem to run all the tests. Yeah. Then maybe you want to only select one or two or three packages to run the tests. Okay. Now, so this is running the tests, but this is actually not giving any useful information, right? So are the tests passing? Are they failing? If they are failing, why are they failing? Where are they failing, right? So we actually need this information. Then how can you get this information? Well, it's very simple. So you can get this information by adding this flag, event handler console direct. Okay? So with this line, we are going to force the output tests here to the console. Okay? Then let's run this command, adding this event handler flag at the end. Now, if we run, let me come here and make this a little bit bigger so that we have a better view. And now I'm going to run this new command. And as you can see now, I am actually being able to see the output. Yeah. So what's going on here? Yeah. So yeah, so here we have many things. We can pay attention to some specific things. So this is the executable, right? This is the executable of my test. Here I can see running one test from one test suite. Yeah. Global test environment set, one test from my first test suite. And then the test that we are running is my first test. Yeah. So here we are running this my first test from my first test suite. Yeah. If you remember the code that we created here in the saving accounts, yeah, the test that we have only defined it one test, which is named my first test, which is part of the my first test suite. Yeah. So this is the expected. We would expect to only get one test because we have only declared one test macro, right? So I am running this test. Yeah, you can see the time, etc. And then 100% of the tests passed. 0 tests failed out of 1. Yeah, so here you can see the output and the summary. So, so in this case, we have run one test which has passed. Okay? Yeah. Okay, then there is another very interesting command that might be worth checking. Which is this colcon test result. Yeah, this command is going to show you the results of the previous tests that have been run. Yeah, so if we run this command, I'm going to copy it here from the notebook and execute it now here. Yeah, this shows me the number of the results of the tests that have been executed. Okay. So in this case, it's 2 tests with 0 errors, 0 failures, and 0 skipped tests. Okay? Now, we can get the test result, again, of a specific package. Okay? Not from all the ROS-based, but from a specific package. So to do this, you can use this command here. Yeah? Colcon test result, and then test result base, and you indicate the name of the package, which our package in this case is my CPP library. Okay? So let's also try out this command very quickly here. Yeah. And we are getting the same output in this case. And then finally, just, yeah, so a couple of things. First, summary. So, running tests, as we have just seen in the process, is a 3-step process. Yeah. So first, you must build your package. Yeah. This is the first step. You have to build your package with colcon build. Okay. Step 2 is to run the tests. Okay. You can run the test with colcon test. Okay. And then finally, you can verify the test results with the colcon test result. Okay? So we have a step 1 to build. Yeah? Colcon build. A step 2, run the tests, colcon test, and a step 3, get the results with colcon test results. Okay? Now we can run, for convenience, the 3 commands at once. Yeah? For instance, here you have an example command. I'm going to copy it here directly from the notebook. Let me clear the shell and paste it here, yeah? So here we are doing first the build, colcon build of my CPP library package. Then I am, after that, after building, I'm going to run a colcon test to run the tests. And after that, yeah, I'm going to check the results with colcon test result. Okay, so here I have the 3 commands and the three steps into one single command. So you can run this, and the output is going to look something like this. Okay? All right. So now, to finish, we are going to update our testing file to include some more tests. Yeah, we are going to make it a bit more complex. And this is going to allow us also to see some of the basic test assertions, the most used ones. Yeah. So far we have been using only one test assertion, which is this expect true. But as you might imagine, there are many more, okay? It's not possible to check all of them because we don't have the time, but we are going to see some of them. So what I want you to do now in this last exercise is to come here to the savings account test CPP file, and we are going to remove the current code. And instead, we are going to copy the one that we have here at the end of the notebook, yeah? So let's copy all this code and paste it here into our file, yeah? So, okay, so here we are having some more tests, right? So we are defining 1, 2, 3, and 4 different test macros. Okay, as you can see, all of them are from the same testing suite, which is savings account. Yeah, this is the testing suite. All of them are from the same testing suite, testing group, but each one of them has different names. Yeah, this first one is named test deposit. This second one is named test deposit and withdraw. This third one is named test excess withdraw. And the final one is named test get name, okay? And each one of them is going to test a different thing, yeah? So this first testing macro, which is named test deposit, as you can see, first of all, we are creating an instance of the savings account class, yeah? Remember, this class is the one which is defined in our library, yeah? This is why, besides doing the include of GTest, we also need to include our library. Okay? So we are creating an instance of our class, and then we call the deposit method. Yeah? And then here we are using a new assertion, which is expect eq. Yeah? Which means expect equal. Okay? Then if I deposit 100 to my account and I call the get balance method, I am expecting to get a balance of 100, right? Yeah? So if I deposit $100, let's say, into my account, and then I check the balance, I am expecting to get $100. So here I am calling the deposit method, and I am depositing 100, okay? And then I am using this expect equal assertion to check that the account balance is 100, yeah? So this assertion is going to check that this first number is equal to this second one, yeah? If it is equal, then the test is going to pass. If it's not equal, the test is going to fail. Yeah? Does it make sense? Do you see what we are doing here? Yes? Okay. I'm getting no answer, so I'm going to assume that you are understanding everything perfectly. Okay. All right, then, yeah, so let's check the next test. Next test is test, deposit, and withdraw, okay? So again, I am generating an instance of the savings account class, and then I am doing a deposit, yeah, again, so I am using the deposit method to deposit this quantity, okay? then this method by itself is going to return a Boolean, okay? So if we check this method in the class, we can do this very easily. This is the deposit method, okay? So if you come to the class and you check the deposit method, yeah, this deposit method, if everything goes okay, is going to return true, okay? So this is what, let me clean a little bit all this. This is the main, which we have already explained it. This is the same. We are running all the tests, yeah? Let me close also here the main CPP and the library header. I have this a little bit more clean, yeah. Okay, so yeah, then this deposit method, as we can check here, is expected to return a true value, yeah? So I am capturing this return here in this deposit result variable, yeah? And then I am checking if the deposit result value is true. Okay? This is the first test that I am doing here. But it's not the only one, yeah? So, so far we have been using only one assertion, yeah? Here we are actually using multiple assertions. So first we are using the expect true assertion, and here we are using another, which is assert float equal, yeah? So after depositing $100.10, yeah, I would expect my balance to be 100.10, right? Then with this assert float equal, I am checking that this first float value is equal to this second float value. Okay? So as you can see, it's basically the same as this expect equal, but for floats, yeah? So expect equal should be used with integers, and assert float equal should be used with floats, okay? Then after this, we are still using another method, which is the withdraw, yeah? Withdraw method. So we are doing a withdraw of $50. Then if my balance is 100.10 and I withdraw 50, I would expect my new balance to be 50.1 or 0.10. Yeah? Yes, no, so far so good. Okay, I'm going to keep going. Yeah? Then in our third test, we are also have multiple assertions, yeah? So here we are doing again a deposit, like in the previous one, and checking that the returned value is true. Here we are checking again the assert float equal. Okay, yeah, so until here, we are doing similar tests. So we are testing the return value from the deposit method, and we are checking that the balance corresponds with what it is expected from the deposit. Yeah. Now here, what we are trying is to withdraw a quantity higher than the current balance. Yeah. So if the balance is 100, what happens if I try to withdraw 500? Yeah, so this is what I am checking in this test. Yeah. So if I try to withdraw a value which is higher than the current balance, I would expect a false value. Yeah. So if we come here to the withdraw method, we see that this is a specific check. Yeah. So if the amount to withdraw is lower than the balance, then the withdraw can be done. So I'm going to return true. Else, so if the amount is higher than the balance, I'm going to return false. Yeah. So here I am trying to withdraw an amount which is higher than the current balance. So I would expect to get a false. Therefore, I use the expect false assertion. Okay. Yeah. And then finally here we have a final test, which is the get name. Yeah, so we are testing the get name method. Yeah. So if you get so we are setting the account name here, yeah, in the constructor, which is holiday savings account. Then I use the getName method. So I would expect the name of my account to be the one I am setting here in the constructor. Okay? So as you can see, this is a very typical case where you are going to have different tests for testing all the different methods of your class. Yeah, so you are going to have one test or more than one test to test the deposit method, one or more tests to test the withdraw method, also to test the getName, getAccountNumber, and getBalance method. Yeah, so you are generally going to create tests, different tests for testing all the methods of your class. Yeah. And yeah, so let's just rerun again the command. So here I'm going to copy the command, and as you can see here, I am doing the build. After that, I'm running the tests, and finally I'm getting the test results. Okay, and I am adding the verbose here at the end, as you can see. So yeah. So I have recompiled. Very important. First step to compile. Second step, run the test. Third step, get the results. Yeah. So 5 tests run, 0 errors, 0 failures, there's 0 skipped. Yeah. So all the tests have passed. Again, if you want, you can run the event handler flag to get a more complete log of the tests. Yeah. So here we can see all the tests that have been run. So the test deposit, yeah, which is the first one that you have defined here. The second one is going to be test deposit and withdraw. Yeah, here you have it, test deposit and withdraw. Next we have the test excess withdraw. Yeah. And the final one is test getName, which we have also here. Yeah. So all the tests have a run, all the tests have passed. Yeah. And yeah, and that's it. So we are going to leave it already here. As I already said at the beginning of the class, so this class is meant to be an introduction, okay? So we have learned how to prepare the environment, how to prepare the ROS2 package, how to include testing into this ROS2 package, and how to create a very basic test file with using some of the basic test assertions. Okay, so this is just a very brief introduction, but we have published this week a new course in our academy, which is this GTest framework for ROS2. I have left here the links to this course. And inside this course, you are going to find many more things related to GTest. Yeah, so for instance, you're going to see how to test actual ROS2 nodes, like subscribers or publishers, how to create full system and subsystem tests, which include gazebo, for instance, and many much more things. Okay, so if you are interested in the topic and you want to keep learning more about this specific subject, yeah, go ahead and have a look to the course. Okay, and yeah, so this is going to be everything for this class. I'm going to leave it here. As always, before actually finishing the class, I'm going to activate here the rate form very quickly. There we go. So that you can rate this class if you liked it, if not. Yeah, giving it 5 stars or 0 stars if you didn't like it at all. Yeah. And yeah, thanks all of you for being here with me during this class. I hope that you enjoyed it. I hope that you found it interesting and that you have learned something from this. And yeah, I will see you again in the next open class next Tuesday. And until then, as always, take care and keep pushing your ROS learning. Bye-bye.